Hello guys and welcome. I hope that you're well. My name is I play 4K, aka I play 8K, aka I play 16K or UHD King. During this video I'm going to show you world's first NFS15 for PC. This is 15 series on PC that was released in 2015 on the consoles and in 2016 on PC, running whopping 16K resolution rendered in real time. Let me real quick go ahead and show it to you, but pretty much it's going to be 133 megapixels rendered in real time. 133 megapixels, guys, okay, rendered in real time, or 16K resolution, which is 15,360 pixels by 8,640 pixels. If you're going to multiply this value, you're going to receive 132.7 megapixels, rounded 133 megapixels, rendered in real time on a single Titan RTX video card, Nvidia Turing GPU architecture, TU102 GPU, and this is the first world gaming video card that allow us to play this game in 16K resolution because of 24 gigabyte of the VRAM. VRAM stands for the video RAM. It's 24 gigabyte of GDDR6, and it's a little bit more than 24,000 megabytes. It's going to be 24,600 megabytes if I'm not mistaken. But anyways, I started, as you can see, as low windowed mode. Because somehow it's just showing me some destruction when I'm running full screen, and it just doesn't want to go in 16K resolution or 12K resolution. It's going back to 8K resolution by itself. Based on my display information system at the left top corner, I can tell it. But this is the maximum font, as you can see, on display information system at the left top corner in 16K resolution under the MSI afterburner. If I'm going to go larger font, it's just going to pretty much distort the writing, and even larger than that, it's not going to display anything. So this is, as you learned already, the maximum possible font for 16K resolution based on my videos when it's rendered in real time. How I achieved that, guys, I'm so excited. This is going to be my first time. I just loaded up and it's loaded. This is amazing. It's rendering, so we can bench it. The purpose of this video is not the gameplay. The purpose of this video is the benchmark. Everybody understand, just because this is the first time 16K resolution, FPS will be low. But keep in mind that this game supporting two Titan RTX and SLi. It's supporting the SLi, guys. I was running even 4-way SLi back on 2016 when I was using 4 Titan X Maxwell GPU architecture and SLi in 4-way SLi by Nvidia. But right now, 2 times SLi, guys, on Titan RTX is possible, but this is only single Titan RTX. Keep in mind that I'm using the old school Xeon E5-2697 V2 CPU that is slightly overclocked by 200 megahertz. It has 12 physical cores, and with the hyper-threading technology, 24 threads or 24 virtual cores. But I shut down 8 cores in the BIOS, and I shut down the hyper-threading technology. So I'm only running 4 physical cores just to make sure that my frequency in-game will be running 3.4 gigahertz. Otherwise, it's running with 12 cores 3.2 gigahertz. Just additional boost of 200 megahertz. Because I cannot control the multiplier on this enterprise CPU, and it's controlled automatically by the BIOS of the motherboard and by the CPU, and through the turbo boost by Intel. So it's using its own multiplier lock and ratios. But this is the maximum, guys, 3.4 when I'm running 4 cores that is possible on any motherboard except the ASUS. ASUS X79 chipset is the best motherboard for X79, and it can push to additional 200 megahertz. So I'm pushing just 200 megahertz from the Intel manufacturer. It's just additional boost, and they can push additional on top of it 200 megahertz. Okay. but I'm using today gigabyte motherboard. This is not my gaming PC. This is my workstation from 2020 that I'm about to retire in 2021. I'm going to switch to two Xeon E5-2699 V3, which is going to be amazing 72 virtual cores or 72 threads combined, and it's going to be a great workstation for 2021. But I decided to go ahead and show you how this particular CPU, Xeon E5-2697 V2, can be in games. But as again, you're building this system as workstation, but if you're on a low budget, you can build this system as all-in-one. And in the end of 2021, this CPU, Xeon E5-2697 V2 on the eBay will be around $79, $89. Keep that in mind. So the whole system without the video card, including the system RAM, DDR3 motherboard, and the processor, you can build for $250, maximum $300, which is amazing. And you can use all-in-one system as workstation for the video encoding, just like I'm using 8K resolution video encoding and 3D rendering. When all the threads are utilized at 100%, like all 24 threads utilized at 100%, this is exactly when you're going to benefit. But you can also run the games. Of course, it's not going to be the fastest because games not utilizing all the threads to the maximum, where you're going to benefit in this type of scenarios using this particular CPU. But you can still run the games, and today we're going to see it, and then I'm going to compare it with my gaming rig in 2019/2021, which will be i9 9900K Intel 9 Gen, because this Xeon is Intel 4 Gen, but that one going to be Intel 9 Gen running 9900K, running 5.3 gigahertz or 5.4 gigahertz with just 2 cores, 2 threads. Okay, but let's go ahead and have a look, guys. This is the maximum possible preset. Let me go ahead and jump back into the game. Hopefully I explain everything what you need to know real quick, because a lot of beginners and people that is not hardcore PC enthusiasts or overclockers watching my YouTube channel, we gotta explain it to everyone, right? So I didn't play it yet. Hopefully it's not going to crash on us, but as you can see, immediately at lowest possible preset, it's utilizing almost 23,000 megabytes. You can see it at the left top corner, guys. You want to keep your eye at the left top corner. Please watch this video on a big screen, and please watch this video in 8K resolution, because today I'm recording this video with Nvidia Shadowplay in real time, but in 8K resolution. It's achieved because the Nvidia Shadowplay, the whole driver is hacked, and the width and height value of the video container is changed from 4K resolution to 8K resolution, and it's recording without any lag in 8K resolution. So this is how I'm going to upload it to the YouTube. But as you can see, almost 23,000 megabytes as the lowest possible preset. I just loaded up the game. Of course, you cannot load the game at 16K in 16K resolution. You gotta get to the server like this on the map, and then you can switch the resolution. Otherwise it's going to crash. Keep that in mind. Server is not going to accept that resolution somehow. It's not the problem of your system, it's problem the way when server is checking if you're cheating or not, and then it can see that your resolution is too high, thinking that you're cheating, and it's going to kick you out. So you gotta load up in a game, and then you can switch above 8K resolution or 8K resolution. Otherwise, server doesn't allow you to play above 5K resolution before you load up the map. Keep that in mind. I also recorded, guys, this game in 12K resolution. Keep that in mind. And I'm going to include the in the video description and in the video comments for you to check it out, and in 8K resolution on this system, as well as 4K resolution. I'm also going to include 4 Titan X Maxwell GPU architecture running in 8K resolution, 7K resolution, and 4K resolution back in 2016, just to compare the power. But 4 Titan X Maxwell GPU architecture, guys, in 8K resolution is beating single Titan RTX. Keep that in mind, in 8K resolution, and beating by about almost 20 FPS. Alright, it's usual, guys. It's lag out over here. It's usually doing that, and I believe as a software developer, the garbage collector is just cleaning the garbage collector, all the not necessary loads. It's cleaning them up, and as you can see, we went from 22,700 to 22,600, so we just clean up 100 megabytes. So just it can see that you're utilizing a lot of VRAM and a lot of system RAM, and it's just clean this up because I loaded up game in 4K resolution, and then I switched to 16K resolution. Okay, as again I explained it to you why I did so, and garbage collector just cleaned that data that was loaded up in 4K resolution all the way to 16K resolution. It does that lag all the time when you're running very high, and when you overloading your VRAM, and when you offloading some data from the VRAM into the system RAM. A garbage collector in this game helping you out a little bit, so it's offloading some unnecessary data. Alright, and at the beginning when you're switching the resolution, just lagging out like for a couple seconds as you saw, and then it's kind of playable. As again, it's not, of course it's not playable status, but it's benchable status, it's runnable status, it's renderable status. And as again, we understand that because this is the first time Need for Speed 15, because this is Need for Speed 15 on PC, and on PC it was released in 2016, and on console and it is again in 2015, but this is 15 series Need for Speed. Sometimes it's called Need for Speed or Need for Speed Reloaded. But guys, check it out, 11 FPS, 16K resolution, single Titan RTX, and keep in mind as again that it supports two-way SLI. Guys, please go ahead and grab yourself your favorite drink. I will try to go ahead and switch to different presets, and the best drink will be green organic tea with the lemon. It's gonna clean up your system pretty well. Or just a clean water with the lemon is just going to be the best, guys, the healthiest drink ever. I'm not advising you to drink any alcohol. Alcohol is very bad for you. Wow, look at this. Wow, oh my god, guys, this is just unbelievable. It's almost like screenshots, and I know, but this is just unbelievable. Alright? Because it's running in real time, 133 megapixels. Real time. And as again, how I achieve that, I'm running 8K resolution screen, native screen with the Nvidia DSR. This is going to be Nvidia native DSR, and how I achieve that is again, the driver is hacked, and I'm using some algorithms to achieve Nvidia native DSR in 16K resolution. Otherwise you're not gonna achieve it would be in just a regular Nvidia driver, alright, because it's maximum capabilities in 8K resolution, but as again it's changeable, and I believe the Nvidia knows the best how to achieve 16K, emulate 16K resolution. I tried before, like get the SATA tools, you know, like third-party tools for the DSR, and they always was not correct when I was comparing them to the Nvidia. And I believe just because Nvidia building video cards, it knows exactly how to emulate the 16K resolution, because pretty much any single resolution that we see on our displays came through their drivers, and they know exactly how to do that. And I trust Nvidia, and this is pretty much, as I believe, will be same FPS and same performance if I would connect this system to the native 16K resolution screen. Hopefully guys this makes sense. So it's rendering 16K resolution in real time, and then it's downscaling after that before it's sending the signal to the cable, to the port, and to the cable to my screen to 8K resolution. But it's rendering. This is how much resources it takes to render 16K resolution in real time. This is, guys, unbelievable. And through the SLI we're going to achieve double performance, at least 1.9 times. This is how SLI scales. One single GPU scaling 99%, and as you can see, single GPU right now scaling 99%, exactly 99%, so we are not wasting any shader cores or CUDA cores, maybe like 40, still 40 shader cores or CUDA cores wasted, because each Titan RTX has 4,340, I believe, CUDA cores, shader cores, and 1% will be like 43 CUDA cores, okay, because it's not utilized at 100%, but 99% is excellent GPU utilization. This is what I'm calling 99-100. And yeah, during this type of scenarios in two-way SLI on Titan RTXs, and as again this game supports SLI, you're going to receive at least 1.9 times, means 2 times of the performance. But guys, I'm going to go ahead and check it out on this particular system. I just want to see why I'm want to check it out on this particular system versus my gaming rig. I'm going to show you on my gaming rig as well, because this system using X79 chipset, and I can run 2 Titan RTXs 16X and 16 lanes on the PCI Express version 3.0, while my gaming rig can run only 8 lanes on the PCI Express 3.0. And we're going to see, because those copycats like Nexus Gamers or Gamers Nexus, Linus, they do not testing in this type of presets in SLI 16x PCI Express 3.0 or 8x PCI Express 3.0. They never tested it. They only tested it in 4K resolution maximum, and it's hard to see. But when you're running 16K resolution, this is exactly when you need that type of bandwidth, okay? Because as you can see, the data loaded in huge amount of sizes into the pipeline, and yeah, it just wow, guys. I mean, this game is still amazing. I believe this game is much better looking game than Need for Speed Heat, and I'm a big fan of this game, and much better looking to my taste. And a lot of people still playing this game online, and as you can see right now, I'm playing this game. For those people who didn't play this game, I can play the single player right now, or at the same level I can play online because at the same time in single player and multiplayer at the same time on this map, okay? And people joining up, and yeah, I can race people, or I can just do the single player missions, campaigns, and it's amazing, guys. This game is still beautiful. As you can see, it has the beautiful visuals. It's just unbelievable. Check it out. And I really like the car. Okay, we got the police officer on our back, and the problem is I gotta escape now, and it's going to be hard, because as you can see, it's kind of hard to play it. As again, guys, I'm recording with Nvidia Shadowplay in 8K resolution in real time as well. And please add 3 FPS to the FPS counter when it's not recording. 3 FPS, okay? Very soon I'm gonna get myself from China the 8K resolution real time recorder. They still fixing it. They told me there is an issue with that. They came up with that device back in 2016. And I purchased it on eBay. It's like a small company, unknown company, and the device was overheated a lot. It's recording 8K resolution in real time. I don't know how to pronounce the company, just a bunch of Chinese characters, but I'm gonna get it back, and I will try to record on that device versus the Nvidia Shadowplay, so we're going to receive the real FPS without the taxing with the Nvidia Shadowplay recording on the same computer. But as again, please add 3 FPS to the left top corner. Guys, I'm so excited. This is just unbelievable what we can see right now. 16K resolution. This is the world's first 16K resolution, so don't forget to smash that like button. Of course, I probably would better to run world's first 16K resolution on my gaming rig with the 2 Titan RTXs and i9 9900K. Probably would show much higher FPS, but just because I'm wrapping up with this workstation from 2020 and to show people that they can still build this system in 2021, in the end of 2021, very cheap, and I decided to go ahead and show it to you guys. And you know, I recorded about 50 videos through the different games for you to study, and if you want to use all-in-one system, workstation, and the gaming system, this very cheap system, it's a great idea, and I'm recorded for you as a fact when I'm going to go ahead and show you all kind of different resolutions, not like 1080p, but all kind of different resolutions, and I will tell you what kind of benefits you can, and when exactly these benefits can be applied, and how you can squeeze them with this type of CPU if you're going to use it as a gaming rig while taking some breaks from your work loads and on this same workstation. But look at this, it's just unbelievable. The visuals, unbelievable. Did you see that steering wheel? That steering wheel, it's a bug. When I'm touring at the high speed, it always does that. I'm not sure why. This is why I think when you developing a games, you want to always think outside of the box. I think as a software developer that game developers of this game didn't think outside of the box, and it's a bug. And this game has a bug after 8K resolution. When you're running 10K resolution, 12K resolution, or 16K resolution, it does this at the high speed. Wow, look at this, something is going on. Wow, we almost 24,000 megabytes VRAM load, and right now it's lagging a little bit. The system RAM utilization, guys, is below 16,000 megabytes, but when we're going to offload a lot of data from the VRAM into the system RAM, you're going to see that system RAM going to increase dramatically, and this is the clear sign that we offloading data from the VRAM into the system RAM to compensate, and Nvidia driver does it. So the DirectX 3D surface in our game that right now rendering our game, DirectX 3D 11 API, is not going to crash the game. So it's trying to offload, it's uploading some data from the VRAM into the system RAM, but as again there is some limit. What we find out when I was running 12K resolution, that limit was above 27,000 megabytes. We offloaded not above 27,000 megabytes, but we pretty much loaded my system RAM all the way to 27,000 megabytes from the 11,000 megabytes. So the limit, guys, is over 16,000 megabytes we can offload in this particular game, data from the VRAM into the system RAM. We find out that in 12K resolution video running on this particular system. Go ahead and check it out. As again, I'm going to put it for you in the video comments, and just for yourself you're going to find out. Wow, 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 wow. You gotta escape that police officer, but it's so hard to do. As you can see, as again, the game status is not playable, but at least it's benchable. So the reason of this video, we can bench it and we can compare with the future systems. Alright, so let me real quick go ahead and switch it, guys. This video is not going to be short, this video is going to be long, because I'm the first YouTuber that covering need for speed in 16K resolution. But by the way, I was the first YouTuber that did it 16K gameplays in PC games, guys. 16K resolution gameplays. It was back in 2016 with my 4 Titan maximum GPU architecture. The first game was Half-Life 2. My old school subscribers probably remember that. Let me know in the comments below if you remember that first video 16K resolution on the YouTube gameplay. And I was the first YouTuber. Alright, so what we're gonna do, we're going to go ahead and start increasing some details. So let's go ahead and start increasing some details. Texture quality. Hopefully the game is not going to crash, as again, I didn't warm up, I didn't play it yet in 16K resolution. I don't know what kind of scenario, how we're going to you know, wrap up this video. If it's going to crash, maybe I'm going to go ahead and wrap up this video, but keep in mind that in the end of this video I'm going to show you more about my PC hardware within the details. I'm going to show you CPU-Z, GPU-Z, MSI Afterburner, and some IDA64 benchmark for those people who would like to compare the systems. So texture quality at ultra. So right now the VRAM utilization should be very high, because texture quality is pretty much stressing our VRAM a lot. So we went from low texture quality to ultra, which is the maximum possible visuals. As you can see right now, we can see clearly the license plate, all the details. It's just so amazing. But the 3D mesh quality right now is still at low. So we have kind of the lowest possible polygons. I'm going to zoom in out for you guys. I'm not going to create any screenshots because there is no such a software that can take a screenshot in this game in 16K resolution. This is the garbage collector. It's going to lag like for about 5 seconds. It's going to offload that low quality texture quality, and it's going to load up now high ultra quality of the texture quality and clean up some VRAM and system RAM and load with the new data. This is exactly what it did. This is what I'm thinking as a software developer. This is kind of making sense to me, because I played with Direct 3D Surface and DirectX APIs previously, like 9 and 11, and today we're running Direct 3D 11 API in this particular game. 11 FPS, still 11 FPS. Amazing FPS. How the Titan RTX is handling it, this is unbelievable. But the FPS is almost as same as when I was running 12K resolution, but the 12K resolution was very close to 16K resolution because I was running 3 8K resolution monitors. We were 32 megapixels away from 16K resolution. Those 3 8K resolution monitors in vertical mode that granted us the 12K resolution was pretty much 100 megapixels, and right now we're running 32 megapixels more, which is 133 megapixels. But doing that type of presets, I was running very high FPS at low. It was like 14, I believe, if I'm not mistaken, or 15 FPS, but at 16K it's 11 FPS. So with dropping the FPS, I'm just curious if we can always squeeze it out to the maximum possible visuals and see how it's going to go. Right now when I'm turning, I can see the steering wheel even, as again this is a bug, even when I'm not at the high speed, as you can see, I can still see it. The game is beautiful, the sounds is amazing in this game. I just in love with this game, guys. Right now I'm playing without the motion blur, but this particular game you want to play with the motion blur. As again, when you're racing in this game, you can see some other people racing each other, or you can race them up, or you can complete the single player mission. And you can pick up this game, guys, below $10 on some services like g2a.com or kingjin.com, and enjoy this game. This game is again playable, still playable, and still, as you can see, great visuals even in 2021, single player or multiplayer. It's amazing. 13 FPS, guys. Oh my god, let me go ahead and do some burnouts because it's going to tax our FPS like crazy. Let's go ahead and do that, shall we? Check it out, guys, just check it out. Now it's a volumetric particles going on over here. Uh-oh. Let me back up and let me try to do it again. And it's probably going to tax a lot of FPS, but let's go ahead and have a look how much FPS is going to take. Oops. 11, still 11. The Titan RTX is handling pretty well, as you can see. Wow, this is unbelievable. Look at this level of details. You can see the debris from the asphalt that you couldn't see at 1080p. And there's so much details going on right now. So much details, guys. It's just wow. Alright. Volumetric particles 10. 9. So we're taxing. It was pretty much right now the FPS is like 12K resolution running maxed out. At 16K resolution, still at lowest possible preset. Textures at low or at ultra, it doesn't matter for the Turing GPU texture for the video cards such as Titan RTX with powered by the TU102 GPU. It just doesn't matter because it's so powerful. It's only taxing the DRAM, but it's not decreasing our performance of our GPU computing power, as you can see. Performance is just still great. Wow, it just... Alright, 9 FPS, so we dropped by 2 FPS while we're doing some burnouts. So burnouts, guys, still taxing on the Turing GPU architecture. We got this information. So Turing GPU architecture is still not fast enough for this game, and volumetric particles is still stressing the GPU and still taxing some FPS. But we still have a crazy FPS. At least it's kind of playable for the old school gamer if you know this game, if you know what I mean. But let's go ahead and do something crazy. I'm going to go ahead and now I'm going to increase without the ambient occlusion. Shadow quality can be at low at any time, and it doesn't matter for the Turing GPU architecture. When you're running above 8K resolution, shadow quality can be at low. It's going to be just the same effect as at ultra at 4K resolution, because shadows will be kind of soft because it's going to be a lot of pixels rendered and they're going to soft that shadows. But let's go ahead and do the geometry details, which is the tessellation on the 3D models on the 3D meshes, which is the polygons count. We're going to increase. Okay, now I can zoom in, zoom out and show you the details, because pretty much right now we're using the textures at ultra and the polygons at maximum at ultra, polygons count at ultra, maximum 3D mesh details. Now I can zoom in using the Microsoft Zoom tool and show you how beautiful this game looks like. Let's go ahead and do it actually right now over here. Let me back out. Okay, back up a little bit. Let me go ahead and zoom in for you guys, and I'm using the Microsoft Zoom tool. As again, I'm running in windowed mode, but my desktop is set in 16K resolution. This is very crucial. You want to set desktop resolution to 16K resolution if you're running windowed mode, 16K resolution, and my scale is set to 100%. In the end of this video, I'm going to show you just in case, but alright, so what's going on over here? What's going on over here? One second, guys, 1 second. Let me bring the zoom tool. Here we go, and let me bring it. Okay, so 500%. So let's go ahead and have a look at this detail. So I don't have to take a screenshots for you guys. We're just gonna see how it's going to look like. Just check this out, guys. At 500%, somehow the license plate wasn't sharp enough at ultra textures. I'm not sure why. What's going on here? The license plate is not still sharp enough. Let me double check if the texture is set to the ultra, because at the ultra the license plate should be sharp. 1 second, let me zoom out. Graphics. Ultra, yeah. That's strange. Should be maxed out. The visual should be maxed out on our license plate. I can see that California, see it's like kind of blurred out, like kind of like the license plate is the textures at low instead of ultra. I'm not sure what's going on. Maybe the game is freaking out right now. We don't know, but it should be sharp. The license plate should be sharp on our car, and it's not. Let me change the camera. It's still not sharp. That's strange. Let me real quick, guys, go ahead and maybe just offloaded some data into the system RAM that details of the license plate, and it's not picking up, not reloading fast. But let me real quick go to high and then back to ultra. Let's see what's going to happen, because the license plate should be sharp. While it's doing that, guys, let me real quick go ahead and bring up the zoom tool, and we're going to have a look. So this is 200%. Look at these details. You're not going to see all those details in the pixels when you play pretty much playing 4K resolution for sure. Even 8K resolution cannot show that amount of pixels details. Look at this. This is 600%. Wow. I mean, let me 1 second, guys. Let me a little bit go lower. While it's rotating like that. Let's go ahead and have a look. Level of details of those pixels. So this is for those people that, can you take a screenshots? No, I cannot, because there is no such a software that can take a screenshot above 10K resolution. This is what I find out. Maybe I'm going to develop one in the future, but there is no such a software. Fraps even doesn't do it. The license plate is still not sharp, as you can see. I'm not sure what's going on with the license plate. But every single details are right here, guys. This is just the amount of details. The amount of these details you're not gonna see while playing 4K resolution and such. Maybe on the car somehow it's going to, but at the distance you're not gonna see it. Like, see that vehicle right there? It has the raindrops. The level of that details at that vehicle you're not gonna see when you're going to play even 4K resolution. Those drops, nope, because it's just far away, and it's not going to, the amount of those details is not going to fit your pixels. Hopefully, guys, this makes sense. Alright, let me real quick go ahead and shut down the zoom tool. We don't need any longer the zoom tool. Let me jump in back to the game. I'm not sure why it's showing that, but it's showing that somehow. It's not showing the license plate correctly. It's kind of blurred out, still blurred out, and Okay, now it's sharp. Okay, now it's sharp. The license plate is sharp now. So let me go ahead and zoom in now. So now I can tell that we're running the for sure we're running the ultra preset in terms of the details, because maybe it didn't switch the details in this 16K resolution. Maybe the whole game engine was freaking out. It's like 16K resolution and it didn't understand what we want for it to show us, because this level of the resolution, there is a possibility some algorithms probably was freaking out. But anyways, 500%, guys. And look at this level of details, the carbon fiber. Oh my god, at 500% on a 16K resolution. So look how clear those pixels, the dirt, every single pixel on the dirt. This is just unbelievable, and this is pretty much the maximum visuals. If I'm going to enable the ambient occlusion, the ambient occlusion is right now is disabled, but pretty much that ambient occlusion is kind of creating this fakey shadows around the edges of the 3D model, of the every single like edge of the 3D mesh. So pretty much like every single, you can see that edge, it's going to create darker side, lighter side, so kind of creating that fakish shadows. Not like retracing, creating the real one, but this one going to create on every single edge the fakish shadows. But anyways, it's like in Photoshop, like internal shadows, if inner shadows effect, if you know what I mean, like inside of the edges of the layer, creating the shadows. Look at this, it's just beautiful, guys. At 500%, all right, it's enough. We saw it, just beautiful, it's just unbelievable. Let me take a screenshot actually right now. I'm going to use it, guys, as probably as a background thumbnail for my video. So ultra mesh, wow, this is just unbelievable. Look at these visuals. Just look at these visuals, guys. Yeah, I can tell for sure that we're using. Let me zoom in that Lamborghini sign real quick, and that for sure we're using right now the ultra details. 12 FPS, still managing. I'm not sure how Nvidia does it, but AMD is out of the door. Then they're going to, they cannot even do it at 8K resolution, guys. What are we talking about? But look at this, when I'm zoom in, the license plate is still not there. I'm not sure what's going on. See that? Did you see that? Something wrong with the license plate, but everything else is just right on point. Look at this level of details. But license plate, when you zoom in, it's just not right, not there. It's not sharp enough. Maybe the whole amount of pixels is just not sharp enough. Maybe it's like 256 by 256, and when I'm doing 16K at this type of things, it probably doesn't. But check it out, guys. It's going to be a Lamborghini sign right now. See that Lambo? Look how sharp it is. Try to zoom in like this in 4K resolution. It's not going to be that great. It's going to be pixelated, believe me. Did you see how that bull was so sharp? Go ahead and rewind it. You're not going to receive it like that if you're going to zoom in 4K resolution. It's going to be so pixelated, believe me, guys. Even in 8K resolution, it's not going to be that sharp, that beautiful, like we just saw. Let me real quick go ahead and while it's doing that, show you the Lamborghini sign, and then I'm going to show you exactly that bull, and I'm going to zoom in that bull like crazy. The license plate, as you can see, no, the license plate is kind of sharp. I believe it's just the pixels. Probably they're using like 256 by 256 pixels. There is a possibility, or maybe 512. But even 512 by 512 pixels at this type of zoom on 16K resolution, not going to be so that clear. But the whole car, the whole details is so clear, because I'm pretty sure the whole car details they're using a healthy probably 2K or even 1K is something. If they're using 1K textures, guys, you're not gonna see all the details of the texture when you're playing. Look at this bull. Look at this bull. not pixelated, so beautiful, so detailed, okay? You're not gonna receive something like that, believe me, guys. Believe me. Alright, so let's go ahead and keep going. Let me go ahead and grab the gamepad. I just grabbed myself a gamepad on sale for 19 bucks. Great gamepad, by the way, on Amazon. And it's like universal for iOS devices, for my iPhone gaming, iPad gaming. There is a lot of gameplay videos will coming for iPlay, 4K.com. For the iOS devices, as well as it's working on the Xbox and Windows, so it's beautiful. This is my fourth time to play on this gamepad, but it's amazing. I advise you to get any on this gamepad. I'm probably going to put some note under my YouTube messaging, guys, for your great gamepad for all-in-one devices, and it's kind of cheap and it's nice looking in your hands and feels great in your hands as well. Now it's great looking, and from China. It's like a non-brand, but it's nice. Look at this, 7 FPS. I'm pretty sure right now we're running the ultra textures and we're running the ultra details because that 7 FPS, but something went there, it jumped out from 7 back to 11 and 12, but again back to 7, so it's struggling. And you can see the system RAM utilization went to almost 17,000 megabytes right now. When I was playing 12K resolution, when I was crashing at the high speed, I saw the maximum system RAM utilization was 27,000 megabytes. Okay, jumping from 11,000 megabytes, because this game pretty much by default supposed to use around 11,000 megabytes of the system RAM when you're playing 8K resolution, 4K resolution. Like it's from 9 to 11, like 9, 10, 11,000 megabytes on the system RAM utilization, depends where you're at the level. So when you see above 11,000 megabytes, this is a clear sign that we're overloading some VRAM, which is the video RAM, and storing some data into the system RAM. But system RAM in our case, DDR3, it's not fast enough comparing to GDDR6, because the GDDR6 is running right now. My Titan RTX, by the way, right now is overclocked. It's running 16,000 megahertz on the GDDR6, 16,000 megahertz, okay? And DDR3 is running only 1400 megahertz. So 14 times less or slower than GDDR6. My DDR3 is 14 times slower than GDDR6, okay? So this is why it's bringing that high latency delay, because it's I think the driver is so smart, but Nvidia driver, and it's uploading some data that we probably cannot see into the system RAM, so we cannot see when it's refreshing while I'm driving. But if it's going to upload some data and it's going to be visible, then you're going to see how the texture is going to pretty much reload itself, and it's going to ogle. It's going to come from bluey to the sharp. But it's not the case in this particular game with the Nvidia driver. It's managing pretty well. Look at this. This was AI. It wasn't the player, I can tell. But when it's happening, when it's visible, you can see how slow the DDR3. And pretty much when it's a lot of textures on the screen, is going to upload from the VRAM into the system RAM, and then it's going to load it for you back from that system RAM. You're going to see that latency delay will jump to like way above 300 milliseconds. Sometimes it's jumping like 900, 2000 milliseconds latency delay. That milliseconds located close to the FPS, as you can see. It's right side on the FPS at the left top corner. So that milliseconds, it's a latency delay between the hardware and the software. We want to keep it as low as possible. 10 milliseconds or below 10 milliseconds is excellent gameplay status. Below 20 milliseconds is very good gameplay status. Below 30 milliseconds is good gameplay status. Below 40 milliseconds is kind of playable gameplay status. Above 40 milliseconds, I call it and consider it as kind of playable, but pretty much benchable. It's not comfortable at all. And when it's reaching above 50 milliseconds, it's completely not playable status. It's still benchable status, and you can still play it, but it's not comfortable at all. And right now, when we're running 157 milliseconds, as you can see at the left top corner, 90 milliseconds, it's pretty much benchable, but it's not comfortable at all and not even playable status. Keep that in mind. Wow, FPS is still 11 FPS. The CPU utilization, as you can see, I'm not bottlenecking this game with my CPU cores, because when you can see that during the gameplay the overall CPU utilization reaching above 90%, this is a clear sign that there is a possibility that you're bottlenecking your gameplay and you're showing lower FPS, bottlenecking by the CPU cores, okay? And but we never saw above that 90% or even 90% of overall CPU utilization. As you can see at the left top corner, it's running about 50% overall CPU utilization on average, and we even didn't see above 70%. So 4 core, 4 threads will be Gucci here when you're running 16K resolution. Keep in mind that higher resolution, the less CPU cores you need. So this is where AMD is going to lose. But the faster frequency for CPU is pretty much where you're going to benefit no matter what resolution. And so the higher frequency pretty much going to show you the higher FPS, because this is exactly when you're going to benefit it. So this is when I'm going to test my, this is what we're going to see when I'm going to test my Core i9 9900K or the clock at 5.3 GHz, because that CPU is already running 2000 MHz or 2 GHz faster than this CPU core per core. So pretty much it's going to show us in terms of the FPS at least 10% FPS boost. But that CPU is 9th generation CPU, and this Intel Xeon E5-2697 V2 will be 4th generation of the Intel Core i CPUs frequency per frequency. So that CPU is 5 more generation above of this CPU. That means every new generation, based on my algorithms and calculation, through my benchmarks, to my experience, I learned that it's going to be only as minimum 3% faster than the previous GPU architecture, than the previous CPU architecture. Sorry, not the GPU, but CPU architecture. Okay, so that means that Intel Core i9 9900K 5 more generation ahead of this CPU architecture. That means 5 times 3, 15%, 15% will be faster as minimum in terms of the FPS. This is applies to the FPS and this type of calculation that I came up with, and it applies to the overall CPU performance as minimum. The next CPU generation will be 3% faster than the previous CPU generation. So 15%, 15% faster in terms of the FPS. But we're going to find out, guys, and I'm most definitely going to run on i9 9900K with single Titan RTX and 2 Titan RTXs and SLi in 2-way SLi by Nvidia on my i9 9900K and my gaming rig from 2018/2021, and that gaming rig running 5.3 GHz, so pretty much it's going to be as fast as 10900K running at 5.1 GHz, okay, by about slower by 200 MHz core per core, frequency per frequency, okay, in terms of the performance when you're comparing 10900K versus 9900K. But I can squeeze that CPU and I able to run 2 cores and sometimes even 4 cores, what we'll see at 5.4 GHz. So I cannot wait, but 5.3 GHz I can run on all 6 cores stable. So 5.3 GHz at least, this is what I'm going to show you in this game. 8K resolution, 12K and 16K resolution, and that gaming rig, don't miss it out. As again, but go ahead and smash that like button for this video. Alright, so we're gonna go ahead and do some crashes right now at 16K resolution, because crashes create some debris. As you can see, it didn't lag, and I'm not sure why it didn't lag, but it wasn't a high-speed crash. It's lagging at the high-speed crash. This is what we learned when I was running the first time 8K resolution in Need for Speed as the first YouTuber in 2016 using 4 Titan X Maxwell GPU architecture. We learned when I was crashing it was lagging big time at the high speed, and right now we learned, and during that time I also was showing the stats, we learned that it was doing because the VRAM overload, okay, and look at this, how beautiful it is, and it's supposed to do it as well over here because we're overloading our VRAM pretty much. As you can see right now, my system RAM dropped from 15,000 megabytes to 9,000 megabytes. So this is, like I told you, exactly how much game is supposed to use. 9,000/11,000 megabytes in this particular game of our system RAM. So the garbage collector offloaded throughout that crash and offloaded the unnecessary data, and it brought us to the exact correct system RAM utilization, which is almost 10,000 megabytes, as you can see at the left top corner. But it's about to go and increase, guys, after the crash, and based by that we can calculate how much data be offloading from the VRAM into the system RAM, and then we can assume how much actually VRAM needed for this game to run 16K resolution. Let's go ahead and do that. I'm going to go ahead and boost up, and I'm gonna crash at high speed. But look at this. This is still right now is high speed, but there is no lag. This is unbelievable. But at ultra, but the game is cheating, as you can see. Game engine is cheating because the license plate is not sharp, and I believe it's not using the textures at ultra. It's probably using the textures at low. Even right now it's ultra. Right now it's get back, as you can see, to ultra texture, but the license plate wasn't sharp. So I believe the game is cheating. So the game engine is probably seeing that the game is about to crash. It probably, as you can see, it's coming from the blurry license plate to a sharp license plate, and I don't think that this is Nvidia driver predicting, because Nvidia driver has no ability to know exactly, or maybe Nvidia driver knows, but I don't think so. I think maybe it's the game engine itself. It can see that VRAM utilization is so high, the stress is so much, and probably it's decreasing the quality automatically, or maybe Nvidia driver does it. But that this is how we achieve that system RAM utilization went from 15,000 megabytes all the way to almost 10,000 megabytes, and it's not a magic, guys. There is something going on here, and I believe Nvidia achieving that through automatically probably decreasing the, look at that, could be a player. No, this is AI. Can decrease, guys, the visual quality of the texture, trying to decrease the VRAM utilization, and by decreasing the VRAM utilization, of course, it's lowering the system RAM, because, as again, we offloading, as you can tell, by VRAM utilization very high, some data into the system RAM. And what I find out, guys, the VRAM offload starts after 20,000 megabytes, and it depends if your VRAM utilization is happening so fast, like jumping from 15,000 megabytes all the way to 20,000 megabytes. It's starting even from 19,000 megabytes. It's the Nvidia driver is predicting, because it doesn't know, so it's predicting in advance. You can see that VRAM utilization is happening so fast, so it's predicting in advance. It's not waiting when the VRAM is going to load up all the way to, oh my god. Don't tell me I'm gonna get busted. That police officer was running for that vehicle, and I think maybe that player was a player actually. It wasn't the AI in that vehicle. But let's go ahead and speed up right now. I'm just going to go ahead and speed up, and we're going to crash very high speed, and we're gonna see what's going to happen, guys. Look at this. Something is going on, guys. Something is not right, because during this type of speeds in 12K resolution on Titan RTX, it was lagging, because VRAM utilization was very high, and system RAM utilization was like reaching above 20,000 megabytes, which is a lot of data offload from the VRAM into the system RAM. But it's not happening in our case over here. It's not, it's just perfect. It's just like in 8K resolution on the Titan RTX. It's just perfect without any lag, or even like a 4K resolution. Look at this. As again, 4 Titan X Maxwell GPU architecture was lagging at 8K resolution, because it's only using 12K. It's only using the 12 gigabytes of VRAM. Okay, we just saw some lag. I think and look at this, from 9,000 megabytes went all the way to 14,000 megabytes. So the garbage collector, alright, he's like, look at this. There's a lot of VRAM utilization. I'm going to offload some data from the VRAM into the system, and 15,000 megabytes right now. And I believe that maybe the game engine was cheating, and maybe at the distance it didn't load the high details in the textures and high details on in terms of the polygons on those 3D meshes. There is a possibility. And now after the garbage collector they pop, and it's like, wow, the settings are so high, I gotta upload some data from the VRAM now into the system, and we jump to 15,000 megabytes. Right now it's lagged a little bit more, as you can see. So I think let's go ahead and try to crash. I believe now the Nvidia driver or game engine is not cheating, and it's loading exactly the visual preset that it should be, and maybe right now it's going to lag. Nope, it's still not lagging, guys. It's still healthy crash. I cannot believe this in 16K resolution. It wasn't like this case of 12K resolution, but as again, we're still kind of running without the ambient occlusion, and ambient occlusion affects me a lot on this Turing GPU architecture. So let me go ahead and switch. But this game, look at this. This game right now without the ambient occlusion, but still with the ultra textures and ultra 3D meshes, it looks like almost like a real lot. Look at this level of details. Yeah, this game is much better lookish game than Need for Speed Heat. Don't you agree, guys? Let me know in the comments down below what do you think. Wow. Look, the asphalt, every single pixel right there on the asphalt, every single scratch, everything going on right here. Let's go ahead and crash. Something is going on. I'm not sure why it's healthy crashes going on over here. It shouldn't be the healthy crashes. We should like... Yeah, I just saw when I was about to crash, I just saw the level of details. Go ahead and press the pause. See, like on that vehicle right there at the left. Let me back up. It doesn't look like the textures. The texture is kind of blurry on that vehicle. See that? Like on that tractor right there. It's not sharp enough. It should be so sharp at 16K resolution. I believe the texture details are right now running at low. And there is a possibility that 3D mesh is not even at ultra. So that's why this is how high we're achieving the below 10,000 megabytes of the system RAM utilization, because right now the system RAM utilization is healthy and VRAM utilization is healthy as well. We're not uploading any data from the VRAM into the system RAM. I can tell it by the system RAM utilization. And it's not lagging, as you can see. It's just perfect, like 4K or 8K resolution on this Titan RTX performance when I'm crashing without any lag. Yeah, guys, there is somebody is cheating, game engine or Nvidia driver, but something is cheating over here. But at least it's not lagging. Look at this. So that means that if I'm going to add 2 Titan RTXs in SLi, we're going to be like 20 FPS, and now it's going to be almost a playable status. We're probably going to cut the latency delay by 2 as well. I cannot wait to test this game 16K resolution with 2 Titan RTXs and on my gaming rig. Maybe we're gonna achieve 25 FPS, and this game is pretty much playable even at 30 FPS if you're old school gamer. Not for those people that get used to the 120 Hz monitors, but for those people that old school PC gamers, 30 FPS in this game is still playable, especially when you're using the gamepad, just like I am right now. Guys, I'm about to switch to ambient occlusion because we're pretty healthy right now. This is unbelievable. I'm not sure how they're achieving that. As again, as a software developer, I concluded that they're cheating, but by lowering the presets. But presets pretty much maxed out, as you can see. Texture at ultra is supposed to be, and geometry at ultra. But let's go ahead and bring the effects. So I want to show you all kind of different presets one by one, and as I told you, this video is not going to be fast. We don't want to run like fast. We're just starting this. This is the world's first 16K resolution. We want to study, we want to receive a lot of feedback. We want to learn how the GPU, how the video card technology reacts to this high resolution, because I believe 16K resolution will be the kingpin of the PC gaming, before PC gaming will be dead in 2025-2027, and everybody will be switching back to a mobile gaming, because mobile CPUs and GPUs will be, okay, now we're lagging, will be fast enough to pretty much play 4K resolution and above beautifully, guys, with the beautiful visuals in 2025, 2027, especially on the iOS devices, like something like A18 chip will be as fast as today GTX 1080 in 4K resolution. I'm pretty sure like A18 chip is going to deliver that CPU and GPU computing power as GTX, wow, look at this, as GTX 1080 Ti in your pocket as mobile device at convenience, and everybody will be switching. That's it. Server kicks us out, guys. Yep, and we crashed completely. The game crashed. Wow. And it's a black screen. That's it. I guess with the level of effects, even without the ambient occlusion, we crashed. We probably overloaded the VRAM like to the level before the Direct3D API, Direct3D surface was crashing on us, and server kicked us out. But black screen, and that's it. And this is without guys, the what I'm gonna do real quick, let me try to load it again. Let me close the game. The game is not even closing. I think the Direct3D surface crashed. Yep, it is crashed. Let me show you what kind of error, just in case. It crashed. Okay, we can go through the debug, but pretty much I can assure you guys there is a VRAM overload for sure. But let me try to go ahead and load it one more time. I just want to load it, and I wanna see if we can play this game with the ambient occlusion, because this was with the effect at maximum visuals. And go ahead and rewind. I didn't keep my eye at the left top when it crashed the game, but the system RAM overload probably was too high, probably something that the Nvidia driver doesn't allow any longer. And so this is what's up, guys. You want to run it like in small resolution. You want to load up all the way to the server. Let me show you how I'm doing it actually, just to go ahead and cover everything. But before I'm gonna do it, let me, while it's loading that, right, let me load up first. Let me load up the game. While it's going to load, I'm going to show you something. I'm just going to show you my desktop is set. You want to make sure that your desktop sets 16K resolution, okay? And you want to make sure also that the scaling is, let me go ahead and bring up at 100%. This is crucial. Let me show it to you guys real quick. Okay, look how small my mouse cursor right there at the left top corner. Let me zoom in there. Okay, so this is exactly what I'm talking about. 15,360 by 8,640 and scaling at 100%. You want to make sure this is like that, okay? So let me real quick go ahead and close that, for the best possible, you know, scenario. This is exactly just to know what's up. So I'm going to go ahead and load up the server. So server, when server can see there's something is going on, there's like a very heavy stressing load on your computer, something is going on, and server can see it, it's going to kick you out. So that's why I'm loading up not at the higher resolution, because what I learned, even when you're going to load up the game at 8K resolution to the server going to kick you out before it's going to load up the map. So you want to load it up at 4K resolution. I'm not sure why it's doing that, but probably server thinking that you're cheating. I can tell you as a software developer, there is a possibility of that. All right. Wow, guys, this video will be so long, as again, I'm going to upload this video in 8K resolution. Go ahead, please watch this video in 8K resolution. It's going to be amazing. I'm probably going to use the software that I'm developing right now, FFmpeg++. It's going to be a freeware. This software is capable to encode or transcode videos all the way to 16K resolution. So I'm going to re-encode this video while I'm recording this video with the hack shadow play in 8K resolution. The file size probably going to be like 120 gigabytes. So like 50 minutes of the 8K resolution recorded with Nvidia shadow play at maximum possible quality at 150 megabit per second is 120 gigabytes of file size. So I'm using my FFmpeg++ application that I'm developing, and I'm capable to use some different codec and using the same 100 megabit 120 megabit per second video compression, video bitrate. I'm capable to decrease my file size to 50 gigabytes, 50, 60 gigabytes, from 120, 130 gigabytes to 50, 60 gigabytes. And that software will be amazing. It's going to include my UHD King presets for the YouTube. Go ahead and check it out. I'm about to release it to the public. It's going to be completely freeware. It's going to be, guys, based on FFmpeg open source developer libraries, but it's going to be just a software. You clicking the buttons, you don't need to know any commands. It's going to be very convenient. You will love it. It's going to be like a user interface pretty much for the FFmpeg++ library for the PCs. And that FFmpeg++, my software, my freeware software, will be capable to, as again, encode all the way to 16K resolution videos. It's going to be the first video encoder available to you guys that is actually capable to encode 16K resolution videos, and it's going to include the CPU and GPU benchmark tool in that, because it's developed by UHD King, right? So this is what's up, guys. I'm going to load up to the server now. I'm going to quit. As you can see, load up the server at this low resolution. This is what you want to do. Do not go above 5K. This is what I learned. Otherwise, the server will crash. When the server will load up, I'm going to be on a level. Then I'm going to go ahead and switch the resolution to 16K resolution. And you want to make sure it's windowed mode, as again, somehow it doesn't want to go above 8K resolution. If it's not windowed mode, it's crashing. Okay, or it's disturbing, or it's a black screen, or it's a gray and green lines. It does something. Somehow this particular game doesn't want to go 16K resolution full screen. So this is why I'm running windowed mode, but it doesn't matter because Windows 10 is still DirectX API. It's still using DirectX API to render every single details, every single Windows. It's still using Direct3D surface. So it's native Direct3D surface. It's not like Windows XP was using the different library, 2D library, and when you were bringing your game into the windowed mode, it was showing lower kind of FPS. It's not the scenarios under the Windows 10, because Windows 10 is using Direct3D surface. Alright, so I load up, alright, oops, not that, load up, as you can see, so I'm on a level. So now what I'm gonna do, I'm just going to go to visuals, and I'm going to say, let me use the magnifier tool. What the heck is that? Square bracket magnifier tool. So it says that it's ready. So we're about to bring it from the window, small windowed mode, to a big one. I think the game is remembering like I was running 4K resolution, and that's probably how the 4K resolution monitor looks on 16K resolution desktop at 100%. Alright, so alright guys, so this is how we left it. I decided to go ahead and show it to you. If it's going to crash again, then we're going to go ahead and wrap it up. I'm just going to show you what kind of system I was running, but look how small my mouse cursor right now, right there at the right top corner. See that? Right top corner. Alright, so we left without the ambient occlusion, right guys? And alright, let me go down. So everything maxed out, effect details maxed out, but without the ambient occlusion. Let's go ahead and try to run it like that. I believe the game crashed. but probably the garbage collector couldn't clean up the old data that went from the different presets, and on top with the new data it's probably crashed. But right now we have a second chance and we just loaded up with this type of preset. So garbage collector right now is kind of real quick clean up, because as again the server load up at 4K resolution, right now 16K resolution. So, and as you can see immediately it starts showing that bad server connection when the garbage collector starting when the garbage collector cleared some data. It happens like that. It happens like that on 4 Titan X Maxwell GPU architecture in 2016. Look at this. This is a player right there. This is the real player. Waiting, we probably can race him, but we're not about to race. Look how beautiful the game looks. Amazing, guys. Those level of details. This is not like that shift. Look at on the asphalt. That asphalt, the level of details, the pixels. And at the distance we can see, still can see the level of details. 4K resolution at the distance, you're not gonna see it. This is a player right there. But as again, we're not here to race. Okay, the police was chasing him. So what I'm gonna do, I'm going to crash right now. I'm going to speed up and we're going to crash. We're gonna see. Oh, I forgot, let me bring the data. Here's the data now, guys. It's still 12 FPS. Let's go ahead and crash now. Bam. Nope. Didn't do anything at the high speed crash. Anything. But the system RAM utilization, as you can see already, almost 13,000 megabytes. So we're uploading some data, that's for sure. And the VRAM utilization is almost 24,000 megabytes. So that's for sure. But still not that much data is uploaded. Yeah. But when I'm crashing, a lot of debris, like some 3D meshes, some sprites, and it's utilizing the VRAM like crazy in this particular game, doing the type of effects. Alright, let's go ahead and have a look. High speed. Bam! Here we go. Have a look at the left top corner, system RAM utilization. So we're going to assume how much of the data. So 11,211 megabytes, right? And 27 immediately, 27,000 megabytes. So 31,000 megabytes. Total system RAM is 32,000 megabytes on this computer, guys. 32 gigs, 4 sticks, 8 gigabytes in quad channel. 32,000 megabytes I'm using right now. I'm using all my system RAM on this computer right now. All the 32 gigabytes and black screen. So what happens, guys? I think what happens, I know what happens now. Why this black screen and why we're getting kicked by the server? I'm overloading my system RAM. And when the system RAM is overloaded, you can store the data into the hard disk, okay? But for this game, it's not fast enough, okay? You can pre-cache data from the system RAM then into the hard disk. This is how it was a long time ago. But for this particular game, nope, not going to happen. So you just saw that above 32,000 megabytes system RAM utilization. So let's assume real quick. So nine, I would say 10 gigabytes healthy system RAM utilization. So 32 and above, it went above. So 22 gigabytes of offload from the VRAM into the system RAM. So pretty much look like Nvidia driver. Wow, I didn't know it before. Looks like Nvidia driver is capable to offload. Is capable to offload 32. Is capable to offload above 22,000 megabytes from the VRAM into the system RAM without direct 3D surface crash. But as again, it depends to the game what we'll learn, okay? Because some games crashing above 5,000 megabytes of system RAM, of the VRAM offloaded into the system RAM. But this particular game took above 22,000 megabytes offload from the VRAM into the system RAM. That means that 24,000 megabytes of our VRAM plus 22,000 megabytes of the system RAM. This is how much exactly the VRAM should be utilized, and even more than that, because we don't know, because this system is using only 32,000 it's 32 gigabytes of the system RAM installed on this system. Okay, so it's a little bit above 32,000 megabytes of the data can be loaded into the system RAM. So to find out exactly how much data I need to have above 32,000 megabytes or 32 gigabytes of my system RAM, and I'm going to test it, guys, on my workstation 2021 with two Xeons E5-2699 V3, because I have above 64 gigabytes of system RAM installed on that system. So what I'm going to do, I'm just going to test it, and we're going to find out with a single Titan RTX and 16K resolution exactly how much at this preset, and as again you saw what was the preset, how much the system RAM utilization, and this wasn't yet the maxed out. So I'm assuming that 16K resolution, probably to run in healthy without any lagging and stuff like that, probably you need to have 64 gigabytes of the VRAM, and I believe this is exactly how much VRAM will be featured on the video cards in 2023, 2024, just before the PC gaming will die, okay, and everybody will be switching to mobile gaming, and just when the first 16K resolution screens will appear on the market for those hardware enthusiasts in 2024, I'm assuming, and I'm assuming this is when the Nvidia will probably featuring 64 gigabyte of VRAM and the gaming video cards start featuring. And I think that 64 gigabytes, guys, required for this game to run completely lag free and in 16K resolution. Okay, so it doesn't matter what kind of GPU you have. Of course, the faster GPU with more shader cores or CUDA cores, the faster performance will be, but the pretty much the reflection over here based on the how much VRAM you have. So I'm assuming at least 22,000 megabytes was offload, so 24,000 of VRAM plus 22, so 46, probably 48 gigabytes needed at this type of preset to run, and this is without the ambient occlusion. When I'm going to switch to ambient occlusion, it's going to be even heavier load on the VRAM. So system RAM, of course, will be overloaded immediately. So I think everything maxed out like this, and including even with the shadow quality, I think that we're talking about 52, 56 gigabytes of the VRAM. So pretty much 64 gigabytes for sure, to make sure that you're not going to receive any lags during the gameplay in 16K resolution. And of course, power probably to play at 60 FPS will be 4 times faster that you, not even 4, 6 times faster that you saw today, the performance. So 6 Titan RTX's performance should be, and we can only run 2 Titan RTXs in SLi, so I would assume that it's probably the year will be 2023 when the GPU computing performance power will reach this type of, not even 2023, 2024, and that's kind of makes sense. I think this is when exactly Nvidia will start featuring the 64 gigabyte of the VRAM. Alright, guys, so this is how we ran it, and remember that preset. This is how I'm going to test on my gaming rig with more system RAM. I will try to install 48, but I don't have the 64 exactly for 4 sticks of the system RAM. But my workstation in 2021 has the 8 slots of the system RAM, and I can install all the way to 256 gigabyte of the system RAM. This is exactly how I'm going to run it on those Xeon E5, 2 Xeons E5 dual socket motherboard, 2 Xeons E5-2699 V3 with the total 72 virtual cores or 72 threads in total. Yeah, we're going to find out, guys, exactly what it is. But this is a great video, so don't forget to smash that like button if you're still hanging out, because you just learned a lot, because those people that left thinking that they receive enough information, that missing out a lot. We just learned exactly what happens as some system engineers, like through the analyzation of the data that I showed you at the left top corner. We saw it with our own eyes, and yeah, we just, through our analysis, we can conclude. So VRAM utilization probably at least 48 gigabytes, but I assume that everything maxed out probably 56 or 52 gigabytes usage on the VRAM. So 64 gigabytes of the VRAM if you want to have the healthy FPS and the low latency delay in terms of the milliseconds. Alright, so right now what I'm gonna do, I'm just going to go ahead and bring for you guys the benchmarks. So we're going to study some specification of my hardware and my system of this workstation 2020, sorry. This is the rendering firm version 1, as you can see, Morozilla rendering firm version 1. This is the picture of it. It's water cooled by the Corsair H100 I RGB Pro, and I believe this is the third generation of H100i coolers by Corsair. I had the first gen, I skip on second, and this is, I believe, the third, if I'm not mistaken, third or fourth, but not second. And this is the picture taken with my iPhone XR. So in 16K resolution, of course, it's kind of noisy because that 12 megapixels or 8 megapixels rendered on and upscale to 133 megapixels. You can see all those pixels noise because every single pixels of that 133 megapixels loaded up with details of the noise of that photo. But over here at the right top corner, my gaming rig from 2019/2021, which is the i9-9900K overclocked to 5.3 gigahertz with 2 Titan RTXs, water cooled with the H150i Pro XT RGB, as you can see. Not RGB but Pro XT Pro, just H150i Pro water cooler by Corsair. It's 360 millimeter radiator, and this one on this workstation is 240 millimeter radiator. Okay, so let's go ahead and talk about the CPU-Z AIDA64 benchmarks. Let's go ahead and bring them all, and GPU-Z, and let me first of all, let me bring the GPU-Z. Guys, please watch this video in 8K resolution. Just switch in your YouTube video player to 4320p or 8K resolution, and please watch it on 8K resolution monitor screen for the best possible visuals. So first of all, right now Titan RTX is running overclock, as you can see. I'm going to create a video tutorial how to overclock the Titan RTX, when I'm going to explain every single step by UHD King, by me. But actually it's plus 100 megahertz on the GPU and plus 1000 megahertz on the VRAM. But VRAM is running 7000 megahertz, but right now it's running 8000 megahertz, which is plus 1000 megahertz. But in terms of the GDDR6, you gotta multiply it by 2, so it's 16,000 megahertz output of our VRAM frequency of GDDR6. So that 1000 megahertz, actually 2000 megahertz actual overclock. So from 14,000 megahertz we went to 16,000 megahertz. Okay, and even under the graphics right here, you can see memory set at 8,000 megahertz instead of 7,000 megahertz as envisioned by the Nvidia. And let me open up the GPU-Z. What's going on with the GPU-Z? I think I open up, but something happened there. Okay. Here we go, GPU-Z. I just want to show you what will happen, how much gain I received through the overclock. And believe me or not, but you're receiving a great, at least 10% boost in terms of the FPS, plus a great digits in terms of the performance. So pixel fill rate 179 gigapixels, textual fill rate 538 gigatasks, and bandwidth is 768 gigabytes per second, right? So let me show you what will happen when I'm going to lower and bring the Titan RTX to a stock. Right now you don't hear it, it's running quiet, nice, because the fan was at 100%. So you saw that Titan RTX was thermal throttling during the gameplay because it was pretty much receiving so much heat and dual fan design. Today I was running Nvidia Titan RTX completely stock, dual fan design by Nvidia, and even the Nvidia thermal compound paste on it. This is not the Titan RTX with liquid metal thermal compound paste. Those Titan RTXs in my gaming rig. But let me real quick go ahead and show it to you guys. So as you can see, we went immediately by 10 gigapixels less to 169 gigapixels. This is, keep in mind, this is how Nvidia envisioned to run this Titan RTX. Tensile fill rate went from 538 to 509 gigatexels, and bandwidth from 758 went to 672 gigabytes per second. So we can achieve a lot of through the just free overclock. But as again, this software overclock I consider home safe environment overclock. But if you're going to repeat everything what you saw during this video, you're doing it on your own risk and expenses. Nobody going to compensate you anything. Keep that in mind. It's very kind of could be dangerous for some folks, but for me, I consider this completely safe, what you saw today. But not a lot, not some people are not going to feel that way. All right. So yeah, this is what's up. This is how the AIDA64 GPU benchmark using the OpenCL API when we can compare GPU versus the CPU. This is the when it's rendering some data, and this is exactly when we compare. But keep in mind that CPU was running only 4 cores when I'm going to enable completely at the full speed like it designed by the Intel with the 12 cores and 24 threads through the hyper-threading technology also enabled in the BIOS. Right now I disable 8 cores in the BIOS, and I disable the hyper-threading technology in the BIOS to be able to run 3.4 gigahertz in our PC game, because the higher frequency at the higher resolution, this is the maximum gain you can gain. Pretty much the higher frequency per CPU, this is no matter what kind of scenario, you're going to gain the maximum gain in PC games. As you can see, cores doesn't gain you anything. 4 cores was more than enough on the NFS15 that was released in 2016 for the PC gamers. Is 4 cores is more than enough in 16K resolution. 8 cores will be more than enough at 1080p, and 6 cores will be more than enough at 8K resolution. But anyways, this is the data. GPU will be always faster than CPU, even when the CPU is going to run 12 cores, 24 threads. GPU will be always faster than that. But just to compare it, keep in mind that GPU was running during this benchmark. GPU was running stock frequencies. This is how the Titan RTX at stock frequencies what it can produce. Okay. And this is the AIDA64 cache and memory benchmark, guys. Read, write, and copy. This is very high, guys. Actually, data performance, read, write, and copy performance for the DDR3. Why? Because DDR3 is running. Let me real quick go ahead and show it to you. Is running in dual channel, in quad channel, which is 256-bit. Dual channel is only 128-bit, but quad channel in theory is supposed to be 2 times faster, but it's not. It's only 1.5 times faster, but it's still faster than dual channel. So pretty much this DDR3 running quad channel is fast as DDR4 running dual channel, 2133 megahertz CL14, CL15. And even faster than DDR4 2133 megahertz CL15 running in dual channel, which is 128-bit. This quad channel, which is 4 sticks, 8 gigabytes, total 32 gigabytes of DDR3. This DDR3 memory was running 1412 megahertz, which is 706 megahertz times 2, 1412 megahertz CL7. The maximum possible stable frequency for this CPU on this motherboard. I heard that on ASUS people can run above 1400 megahertz, but on the Gigabyte, this particular Gigabyte X79 UD3, which is ultra durable version 1.1, with the F20 BIOS from a Gigabyte website, the latest BIOS that was released in March 19, 2014, that this is the only BIOS that is capable to run and post and boot this CPU, this particular CPU, which is the flagship from 2013-2014, 24 threads. Only with this BIOS, you gotta update the BIOS first, and update the BIOS like I did with i7-4930K or whatever the i7 you have, and then when you after the BIOS flash, go ahead and install the CPU. Otherwise, it's simply not going to post. It doesn't apply to any other CPUs, but only for this CPU on this particular motherboard. But what I heard, guys, that on the ASUS X79 chipset motherboard, which is the best motherboard for the Xeon's E5-2600 series V2 CPUs, even for this flagship, you can push DDR4 or DDR3, DDR3 in quad channel above 1400 MHz. But this motherboard doesn't go above 1400 MHz for this CPU. For the i7 in this particular memory, which is the DDR3, as you can see, but can run 1866 at CL9, I can push this memory with i7 4930K running above 2000 MHz on this particular motherboard with this particular BIOS. But that as the gaming CPU, and this is flagship workstation enterprise CPU for data centers, and very pretty much picky about the frequencies. And just like the V3 Xeon's E5-2600 series as well, but ASUS somehow achieved with the X79 can go above 2000 MHz. But actually this CPU is not designed to run above 1333 MHz DDR3, keep that in mind. So even 1400 MHz is already overclock on the CPU memory potentials that are designed by Intel from the stock. But this particular motherboard doesn't allow to run this DDR3 above 1400 MHz for this particular CPU. It's just simply not booting up completely, not posting even. Okay, so you gotta reset the BIOS, remove the battery, and then boot up at 10,066 megahertz the DDR3 and set back to frequency that is postable, bootable. Okay, so what else? Of course, 4-core 4 threads, only physical cores for the best possible performance. What I learned, the hyper-threading threads, when the hyper-threading technology is enabled, 3.7 of those threads is equal one physical thread from one physical core. So you can see how slow they are. 3.7 hyper-threading threads is equal one physical thread. So I decided to run only physical cores, physical threads. Of course, hyper-threading technology will help you when you're going to have a lot of them. In my case, it's extra 12 of them. When you're going to utilize all the threads at 100%, let's say running 8K resolution video encoding like I'm doing through my FFmpeg. I'm about to re-encode this video from Nvidia Shadowplay to different codec to compress the file size with the same visual quality. Keep that in mind. Same visual quality, same bitrate, but file size will go from 130 gigabytes to 60 gigabytes before I'm going to upload to YouTube, because YouTube has the limitation to 100 gigabytes uploads. And yeah, during that type of FFmpeg++ application that I'm developing, as you already learned during this video, I'm going to utilize all the 24 threads completely 100%. So this is exactly when I'm going to take the advantage of the hyper-threading threads. Keep that in mind. Otherwise, if you're playing games, you want to shut down, disable your hyper-threading technology. Keep that in mind. So I was sharing the 30 megabytes of the level 3 cache because it's shared between the cores, between the 4 cores instead of 12 cores. So pretty much it was 6.5 megabytes per each core versus 2 megabytes per each core. So if you're taking advantage and pre-caching some data into the CPU level 3 cache, pretty much this is the fastest possible scenario for the X79 chipset if you're going to play the games. But not a lot of games taking advantage of the level 3 CPU cache, keep that in mind. But if during this gameplay it was taking advantage, then we are another Gucci level. Okay guys, 3.4 gigahertz as you can see. So pretty much how I achieved that, I cheated, and you cannot overclock it through the multiplier because multiplier is locked and it's controlled automatically by the BIOS of the motherboard, and that BIOS of the motherboard is not hackable, not like on V3 motherboard that I'm going to teach you how to hack the BIOS and how to pretty much control the multiplier. But over here you cannot control the multiplier. So how I did it, I still overclock it additional by 200 megahertz, because if I will be running this CPU at stock, I would be running this CPU 3200 megahertz, which is 3.2 gigahertz. But right now, as you can see, it's 3400 megahertz, which is 3.4 gigahertz. So I achieved 200 megahertz additional turbo boost and additional overclock through some cheating methods. And how I did it, pretty much in the BIOS through the BCLK frequency, it's running 100 megahertz. I increased it to 106 and 6 megahertz additional, but that's 6 megahertz additional times 32 multiplier, which right now is kind of locked when you're only running 4-core 4 threads, which is not jumping, and it's nice. It's completely locked, and it's completely this 3.4 gigahertz frequency when we need that frequency. And as again, in PC games, you need that frequency, and you don't want it back to 2.7 like this CPU is running. A stock 2.7. You want to completely in PC games running the stable, highest possible frequency. If I will be running two cores, I will be running 3.6 over here with my additional BCLK frequency overclock. But anyways, 106 times 32 is 3.4 instead of 100 times 32, 3.2. Hopefully, guys, this makes sense. And you can do it through the motherboard BIOS. Just go in motherboard BIOS, hit by pressing delete, and overclock it. 106 is still stable on this motherboard. And as you can see, my CPU is undervolted as well. And it's running great, below 1.2 volts. It never goes below the frequency with this overclock, which is amazing. And with fall cores, I'm running 3.2 as again, with Tori multiplier versus 3 gigahertz. So versus 3000 megahertz, I'm running 3200 megahertz. No matter what kind of scenario, I'm still 2000 megahertz additional overclock through some cheating method, not through the multiplier. But as again, 200 megahertz, not bad for free, right? And as again, in PC games, you want to have as high as possible. All right. So what else? I covered everything what you need to know. This is how it bench. As you can see, this CPU is great, guys. It's loving it. 4 cores, 4 threads, all the way to 12 cores without the hyper-threading technology is scaling so well. As you can see, multi-thread ratio on 4 cores is above 4 times, which is excellent scaling. This is not going to be the case on the gaming CPUs, guys. You're going to, even with 4 cores or 6 cores or 8 cores, you're not going to scale here multi-thread ratio under the CPU-Z benchmark 8 times. You're going to be like 7.68. It's not going to be perfect, but as you can see in our scenario, it's perfect on this particular CPU. So we healthy scaling and excellent scaling actually, because that probably that shared level third cache. Okay, we're pre-caching some data and we're boosting up in terms of the multi-thread benchmarks. We're gonna gain some advantages if we are not utilizing 12 cores, by shut down some cores, by sharing some level toward cache, and so each core will receive more level toward cache and is going to pre-cache some data and is going to boost up and is going to be a little bit faster than it's supposed to be. Okay, so 340, as you can see, single thread performance when I'm running 2 core 2 threads, it's 350. Okay, so this is the scenario. Let me real quick compare it, but as again, this is CPU from 2013-2014. Single thread will be the best for the gaming. Multi-thread will be the best for the as workstation when 100% each core utilized. But as again, this is only 4 core 4 threads, so don't look at my multi-thread benchmark score to compare with this course, because as again, I was only running 4 core 4 threads. When I'm running 12 cores, 24 threads, is way above than that. It's about 5,000 score. Keep that in mind. Okay, but real quick, I'm gonna go ahead and show you comparing with these CPUs. Go ahead and press the pause button. And this is a great system because I grabbed this CPU in beginning of 2020 for $129, but this CPU in end of 2021, beginning of 2022 will cost $79, $89, and you can grab yourself Chinese motherboard for like $50, $79, single socket board. It's nice for $50, or dual socket for like below $100, and 2 of them for $89 each. It's going to be a great workstation for 3D rendering when 48 threads will be utilized. For 2 CPUs, it's going to be 48 threads, like 48 virtual cores, or even single thread, single CPUs, guys. As you can see, it's still great enough. All right. So it's a great build for workstation, for your secondary rig, like for your video rendering rig in my case, or even for all budget all-in-one system. Alright, guys, hopefully, guys, I provided you all the valuable information during this video. Hopefully, guys, you learned a lot, and I'm enjoying this CPU, but I'm about to retire this. I'm going to sell this CPU while it didn't lose the value. It's still $120 used like new, so this is how I'm going to sell it. And I got myself each E5-2699 V3, which is 18 cores, 18 physical cores, but 36 threads on each 2 of them on dual socket Chinese motherboard. Those videos will come into UHDking.com YouTube channel. I'm going to teach you how to hack the BIOS on that V3 X99 motherboard, how to run those 2 CPUs from 2.3 gigahertz that Intel envisioned all the way to 3.6 gigahertz, and beating the Ryzen 5950X. And I grabbed each of those CPU from the local e-recycle company, $149 for one, for $250 for 2. It was amazing, and it's going to be a great value. It's going to be a great workstation for 2021. Well, I'm going to retire this system, sell it, and convert that cash toward that X99. So this is a smart build. Hopefully you learned a lot during this video. As again, my name is I Play 4K, aka I Play 8K, aka I Play 16K, or UHD King. Don't forget to smash that like button. A lot of time, money, energy was invested. Subscribe for more great videos. Visit the iPlay16k.com for 16K resolution videos. And I was the first YouTuber that showed you guys 16K resolution gameplays back in 2016, and I continue this tradition. Support me visiting my sponsors, so I'm gonna get some money because it's coming out of my pocket. Nobody's sponsoring me, guys, and I'm not a rich guy, so please visit my sponsors, support me, and I'm going to show you the newer hardware pushed to the maximum limits, and I'm going to show you how to do it, how to overclock it, how to squeeze every single performance from that hardware. All right, have a great day, stay safe, and I will see you guys till the next videos.